Imagine a chemical plant that can predict failures before they happen, optimize itself in real time, and even design new processes without human trial and error. Sound futuristic? Well, it's already happening. In today's video, we are diving into how artificial intelligence is transforming chemical engineering from design to operation and what it means for students and professionals like you. Hello everyone, welcome back to Chemical Engineering and Aspen channel. If you are a chemical engineering student, researcher, or professional, this topic is no longer optional. AI is becoming a core skill. Let's break it down in a simple and practical way, and it is the next industrial revolution. The dawn of intelligent chemistry. Once we talk about the artificial intelligence, it is fundamentally reshaping chemical engineering, moving beyond traditional digital simulations like Aspen, like ChemCAD, like different softwares towards advanced AI driven approaches that were unimaginable a decade ago. This transformation spans every scale of the discipline, from the precise design of the individual molecules to the intelligent orchestration of entire factory operations. Now, if we talk about three aspects, that number one is the high efficiency, that to optimize the process far beyond the human capability, that to develop the optimizers or the algorithms that could ensure much more efficient plant operations. Low carbon emissions driving sustainability across industrial operations and multi-scale from molecular design to full plant automation. Now, once we talk about the revolutionizing molecular design and discovery, there are three key aspects. Number one is the intelligent capture, number two is generative models, and number three is catalysis revolution. The work which has been done previously in laboratory and multiple years were spent before finalizing our design. AI can do this very quickly or in a comparatively lesser time in much precise way. Once we talk about the generative models, that to develop novel solvents, reagents, and materials through AI guided high throughput screening. And once we talk about the catalysis revolution, that to accelerate heterogeneous catalysis research, fast tracking the discovery and optimization of next generation catalytic materials. AI is integrating very much into chemical engineering. Optimizing processes at scale is our next point, that there are three main parts: hybrid frameworks, in which we have to combine the models with data driven AI for robust industrial applications. The separation systems, very complex separation systems, include distillation, membranes, improved prediction, diagnosis, and adaptive control of complex separation processes. Then waste reduction, that we want our real time processes to have the equipment or the sensors that can adjust the process parameters to ensure that we have minimum waste generation in terms of the solid waste, liquid waste, gaseous waste, or even in terms of energy use. From molecules to factories, that AI seamlessly scales intelligence from atomic level design to plant wide operations, like from the paperwork to the real time of phenomena or real time application. The artificial intelligence have been integrated in the field of chemical engineering to ensure that we get the best performance, the best yield. Now we talk about the industrial impact. There are three main impacts on industry. Number one is efficiency, number two is sustainability, and number three is safety. Once we talk about the predictive maintenance, that it can predict the operation failures before they can occur. And obviously, you can minimize the downtime because downtime means there is no production, there is no raw material intake, no production in the system, and you have to obviously these are the waste days in terms of productivity. But with AI in system, you can predict that this piece is now going towards the deterioration and you can replace it while going for the big shutdown and obviously ensuring the plant safety. Once we talk about the quality control, that it can ensure that our products are prepared within the given range, or like if we talk about the boiler feed water chemistry as an example, that our results are within the range or how much dosing has to be increased of which chemical or of which chemical to be decreased. AI can definitely predict it and can help in improving the plant operations. Or if we by this, we do not have to wait for the laboratory reports. We can get the results instantly. It can provide the efficiency enhancements by generating the energy saving potential across plant operations that can obviously help us in reducing the energy loss, can help in energy minimization throughout the process, and obviously increasing the sustainability of the process. Talking about the digital twins and reinforcement learning data and other aspect of artificial intelligence, that it acts as a living bridge between big industrial data and physical process, continuously learning, adapting, and optimizing in real time to boost both efficiency and sustainability. And once we talk about the reinforcement strategies, that cutting edge reinforcement learning algorithms are transforming solvent design, delivering safer, more environmental friendly, carbon reduced chemical separation processes at industrial scales. We can design, we can optimize, we can revolutionize the conventional processes using these capabilities of artificial intelligence. Now we'll talk about the overcoming challenges, which is the data in integration, that despite the significance, the ability of AI, the widespread AI adoption in chemical engineering faces significant hurdles that must be addressed deliberately. Like in curriculum integration, it should be adopted, then bridging the expertise gap that combining diverse data types, aligning data scientists and operators, data underutilization as well. So obviously we need that we have to train the people, we have to train our focal persons, our faculty, our industrialists to ensure that this tool is integrated not only in the courses but in the real time as well. Now we talk about the future of AI is that adaptive control and responsible innovation. Now we talk about the highly automated future that it provides or it promises to be an it promises to be a novel area or a new area of highly automated self-correcting control system capable of managing the industrial processes with more precision, more accuracy without harming anyone at the plant and adopting such controls in the process that even humans cannot meet or humans cannot do. And once we talk about the responsible innovation, that it should be transparent, it should consider the ethical considerations, transparency in AI decision making, accountability in high stakes environment, and a commitment to addressing the world's most complex chemical and environmental challenges. So these futures or these futuristic approach should be considered once we are adopting AI in our curriculum, in our real-time plant operations. And finally, once we talk about, or if we summarize it, that AI is not merely an enhancement to chemical engineering, It's a paradigm shift, fundamentally redefining how we design molecules, run processes, ensure safety, and pursue sustainability. And these are the three key points: efficiency, sustainability, and innovation. AI is not replacing chemical engineers, it's enhancing them. The future belongs to engineers who can combine process knowledge, data skills, AI tools. If you found this video helpful, don't forget to like, share, and subscribe. And let me know in the comments should I make a tutorial on AI tools for chemical engineers. Till then, it's goodbye. Stay tuned for more exciting videos on this channel.